afternoon, everyone. My name is Tim Payne, and I'm going to be talking about the joys of DevOps, the what, the why, and the how. So just a couple of points of order before I start. The first thing is that, yes, as Kylie mentioned, I will be taking questions at a couple of points during the presentation. So please sort of put your questions into the Q&A box, and I will try to address them as best as I can. And second point of order is that this presentation does contain more information than I will actually be talking about. As DevOps is quite a big area and it sort of requires quite a large knowledge base, I put thoughts and articles within this presentation that I thought might be relevant to some of what I'm discussing, so that once the presentation is over, you can actually take this slide deck or take the PDF and basically go away, read those articles, give some thoughts to the material that I discuss. And if you want, you can even contact me. I've got my LinkedIn profile here, and you can ask me and I'll try to help. Okay, so with that, let's get started on to the fun stuff. Right, so here's the agenda for today. We'll start off by doing a 30-second intro into who I am, and that's going to be really fascinating because I'm a really fascinating person. Then we'll talk a bit about what is DevOps and why do we do it. Then we'll talk a bit about the typical issues that organizations need to solve when you started looking at implementing DevOps. We'll talk about some of the possible solutions to those issues. And then I'll talk about some of the implementation roadmaps that I've used in the past with clients that have worked actually quite well. And then we'll have a summary. Okay, so just a couple of light points. We're only going to be taking a light look at DevOps today, not deep diving it. That's because if we were going to deep dive DevOps, we'd be here for far more than an hour. I'm sure everyone's got better things to do with their day than sort of listen to me discussing DevOps all day. And the second thing is that we're actually discussing enterprise scale DevOps, not single team or a couple of teams DevOps. They are quite different in the types of issues that we need to look at. Okay, so with those under your belt, so to speak, let's have a look at what is DevOps. Oh, okay, yes. Let's just start by looking at what is me. So basically, my name is Tim Payne. I work for a consultancy called Digital at the moment. I've been in the IT industry for over 25 years. It sounds horrible when you put it like that. For the majority of that time, I've actually been in the software development space, in the verticals of CM, SCM, build management, DevOps before it was actually called DevOps, and requirements management and release management. All to do with things like processes, how you track processes and how you track assets in processes. I've done quite a lot of roles within that. So I've been a developer, I've been an architect, I've been support, I've been a test. So I have been around the block quite a bit. About 10 years ago, I sort of started primarily doing consultancy. And for the last 10 years, I've been effectively a DevOps architect and a DevOps consultant, working for various consultancy companies, helping their clients move to a successful DevOps implementation, which surprisingly is why I'm here to talk about DevOps today. So that's me. My LinkedIn profile is there if you want to have a look at what more I do. So let's actually get on to some topics of interest, like what is DevOps and why do it? Now, DevOps is one of those large, fluffy buzz terms that's been around for a good number of years that means a lot of different things to a lot of different people. To some people, it means things like cloud. To others, it means things like CI/CD. And to other people, it means things like ways of working. None of these definitions are wrong. They just capture different aspects of DevOps. So when I talk to clients about DevOps, what I tend to do is I tend to focus on this definition. So DevOps is about having an enterprise level culture and process that focuses on achieving a quicker and more stable release cadence. And the key word there is release cadence. So I'm focusing or trying to get the people I'm talking to focus on the release, because that's really the key thing that you're worried about with DevOps. It's getting releases out the door quicker and more stable. How you do it, well, that's what the guts of DevOps is about. But the definition, as far as I'm concerned, is sort of looking at that release cadence. How can you get that release out the door quicker? And the 4 pillars that I used to sort of talk about doing that is having trust. That's trust between groups, trust between functional areas, and trust between teams. It's having repeatability. So that's making sure that the release processes and the parts of the release processes that you do are all repeatable. It's about having automation so that you can take those repeatable processes, you can automate them so that they can be achieved very quickly and in a consistent fashion. And lastly, it's about shift left, which is basically about having rapid feedback on changes. So if someone introduces a change, that within 5 or 10 minutes, they can get notification that their change has actually broken something. And as we all know, it's much cheaper and easier to fix problems nearer the source than it is further on down the pipeline. So that's really what I would regard as being DevOps. But is that all? Is that all we need to worry about? Oh, no, of course it doesn't. So when we talk about DevOps, yes, release cadence is a part, but we also have to worry about things like ops, obviously, because it's part of the DevOps definition. And we also, these days, also need to worry about cloud. In fact, I think it would be true to say over the last 6 to 7 years, I've had no project that hasn't had a cloud component. And as soon as we start to talk about cloud, then we start to talk about these 2 main areas, which you may have heard of before or you may not have. The first one is cloud strategy, and the second one is SRE, or also known as site reliability engineering, which is effectively ops for cloud. Now, this is where I start to provide some links in the presentation to actually talk a bit more about these topics because they are quite involved. So if we're talking about cloud strategy, what are we talking about? Well, we're talking about things like cloud migration. You know, what type of services are we migrating to the cloud? What type of infrastructure are we migrating? And how are we going to do that migration? We're talking about cost controls. You know, we're moving from a CapEx model, which is capital expenditure, to more of a metered OpEx model. So how are we going to do that? And how are we going to ensure that developers with the ability to create infrastructure at will don't go mad and start creating things that they don't actually need? We're talking about security. So we've moved our infrastructure, we've moved our application away from our bricks and mortar barriers into that waffy, cloudy thing called the cloud. So how do we make sure that that implementation is now secure? You know, theoretically, it's open to the public, it's open to the world. How do we tie it down so that we make sure that only the people that we're interested in accessing can access it? And then how do we deal with security incidents if they occur? And just a heads up, that's where SIEM and SOAR sort of come into the role. And then we're talking about architecture and topology. You know, the cloud does lots of things in a better way than you can do on premise. So how do you look at either redesigning or designing your applications and infrastructure so that they actually work best with cloud? And then finally, we consider things like hybrid services. You know, we might have some services in our cloud that need to talk to things that are on premise that we can't migrate to the cloud. You know, there might be some services that we've lost the code for, or that we don't have the code for anymore, or that might be mainframe services that we need to interact, but we can't actually migrate them to the cloud. Or it might even be that we have services that are hosted in other cloud providers because they're provided as sort of like third-party services that we still need to integrate with that. So we need to sort of consider how we're going to do that hybrid integration. When we talk about site reliability, we need to consider things like observability and monitoring strategies. So how are we going to do the alerting and incident detection? How are we going to sort of get some visibility into how the application is working, how the infrastructure is working? So things like metrics, logging, tracing, and context, that's all very important. And if something does happen to our infrastructure in the cloud, how are we going to actually monitor that incident? How are we going to raise those incidents? How are we going to communicate those incidents to the customer so that they're aware of what's happening and what we're doing to resolve it? And of course, we've got the old disaster recovery, which is a common challenge for any infrastructure, whether it's managed by the cloud provider or it's managed by us in the cloud directly. So we need to consider things like, you know, disaster recovery, failover. If we have systems that we've set up ourselves, so how are we going to recover those versus if they're managed services that are provided by the cloud and sort of managed by the actual cloud vendor, get the right word, how are they actually going to interact together? Then we're talking about things like availability and resource elasticity. So if we've got sort of like a metric we set for ourselves, or an SLA that we set for ourselves, which is like 99.99999% availability, how are we going to sort of fulfill that? And then finally, we're talking things like ITSM, CM, HAM and SAM, inventory management. How do we profile and manage the assets that we're using? How do we profile and manage the services that we're using? And how do we share service catalogs that can be used by our developers, by our ops teams, so that they have access to, say, maybe infrastructure that's being developed that they want to deploy? So all of those are types of concerns that are relevant to DevOps and relevant to the cloud. So is that all? That's enough, but is there anything else we need to worry about? Oh, yes. Yes, the final two I usually talk about are things like organizational changes and automation. Now, for organizational changes, if we're going to move teams to support the cloud or releases going into production very quickly, then obviously we're going to have to change the way teams are structured. We're going to have to get them to work close together. Or maybe we even have a multidisciplinary single team that owns both the development, deployment, maintenance, and production implementation of their components. We're talking about moving from a CapEx model to an OpEx model. So how are we going to sort of manage that change that we're rolling out to the organization? So that's a big area that we need to be concerned with. And of course, the last area, as far as I'm concerned anyway, is actually doing the automation. I mean, it's all very good and true talking about sort of CI/CD, talking about running things quickly, but the only way we can do that is through automating them. So how are we going to do that automation? How are we going to take these sort of processes that each of the teams run and actually tie them down to the point that we can automate them? And of course, then we need to worry about, how do we automate the deployments to the cloud? How do we automate the SRE practices that we talked about, keep the cloud running and keeping our services live in the cloud? We also talk about, how do we automate the budgeting so we make sure that the services that we have deployed to the cloud don't suddenly start racking out large bills in unexpected ways. So all of those things are things that we need to consider when we actually start to do any DevOps implementation. So that's quite a large topic. That's quite a lot of change that we need to do. That's quite a lot of investment that we would actually need to put under our belts to actually do DevOps. So why would we actually want to do this? What would the benefits that we actually get out of it? The main thing, for me at least, is the ability to release the market quicker. Gone are the days where you can sort of say, oh, okay, customer is demanding lots of new functionality. We can release it in 3 or 4 months or even 6 months or a year, and then everyone will be happy. No, the world doesn't work like that anymore. Everyone needs to adapt to change much more quicker, which means that if a feature comes in that the customer is requiring, then we need to get that feature out ASAP, either so that we can gain competitive advantage over our competitors, or that we can stay at the same level as our competitors. The saying is your competitor is only a link away or a click away is more true now than ever, especially in the retail space. So we need to have the ability to get any changes that we need out to the market quicker. And the only way we do that is by basically automating the delivery process. Next one would be to actually improve release quality. Now, if we make the release process automated, we make the release process more repeatable, and we actually start to introduce more testing into the release process or more quality into that release process, whether we do static code analysis or we do security analysis or we improve functionality, then that's going to have an accumulative ability to increase the quality of our releases. So improving release quality is almost like a side effect of doing DevOps. Second one, or third one, it makes releases more routine and repeatable. There's nothing more fun, if you like, than planning for a big bang release. So you have to tie up lots of critical resources for hours on end, deciding when resources are going, when environments are going to be available, defining when tests are going to be done, defining what phases your release is going through. Then, of course, you do your deployment and you have all your war rooms, and you tie up yet more critical resources into those war rooms for days on end. That costs money. You can't really afford to do that anymore. So what we want to do is we want to make releases more routine and repeatable so that we can actually start to invest the time of those critical resources in delivering value and not just doing repeatable tasks. And then finally, why in this question of why do we do DevOps, it's to take advantage of the cloud to help us do things like migrate costs, manage security, and manage resource elasticity more effectively. So if we put all of that together, what we're trying to achieve is basically we want to develop a delivery process that is quick, automated, reliable, and mundane, i.e. not a major effort every time we're going to try and do a release. So hopefully that's sort of fairly clear, but let's have the first sort of break for questions before we move on to the next section. So I think any questions that people are screaming out that I might be able to answer?
So we do have one from Alan. He says, what percentage of development follows DevOps methodology nowadays?
Good question.
And I wonder if we need to distinguish between Agile and DevOps. I don't know,
yeah, because a lot of them, it's very difficult to distinguish those nowadays because, you can't really do DevOps without being Agile. And when you do Agile, you usually do DevOps as a result of being Agile. I did see some figures recently, but I can't remember what they were. So I think that's a very good question, but I think it's one we're going to have to come back to. But I can say that all the projects I've been involved with certainly have been doing DevOps recently. So that's 100%.
Sample bias there, though, Tim.
Yes.
Unfortunately.
Yes. Oh well. No, it's a very good question, but unfortunately, I don't have any up-to-date figures to help answer that.
Cool. Okay, so that's the only one that's come in so far.
Okay, cool. So let's move on to the next section. What are typical issues organizations need to solve when looking at implementing DevOps? Well, there are many, but I tend to classify them into three types. There's the cultural issues, which also includes, people and organizations. There's the process issues, and then there's the technology issues. And this is where I'm going to start diving into a bit of detail. So when we talk about culture, what we're talking about is things like politics and trust. Now, as soon as you start to roll out any organizational change, especially when it involves in sort of changes to the landscape and how functional units are structured, there's always going to be politics. You can guarantee it. It's mainly to do with things like power plays. People are worried about them actually the parts of the organization losing its prestige. So you need to sort of navigate how you're going to actually deal with that, how you're going to sort of alleviate some of those problems. For trust, it's basically if you have silos where basically teams are sort of saying, you provide something to us, we will sort of validate what you've done and we'll validate it again, and then we'll pass it on to the next one into the chain who will then validate what we've done. That sort of infers that there's a lack of trust between the silos that you need to worry about. So you, in a highly sort of segmented organization, you need to sort of think about how can you sort of start to build up that trust between the different functional units. The organizational inertia. Oh yes, good one that. People and organizations by sort of their nature dislike change. So if you have a very large organization with fairly structured and it's fairly bureaucratic in nature, as long as I get the word right, then it can be very difficult to actually get changes pushed through. You have to overcome that organizational inertia. lack of ownership or too much ownership. This can also be a challenge is if you're dealing with some DevOps piece that has multiple components that you're having to worry about, you obviously will start to run into challenges where you're going to have to deal with multiple owners. And as we all know that working with a committee can be a bit of a challenge, certainly when you want a decision out of that committee. So you have to sort of navigate how can you find the right owner, or how can you find the right combination of owners so that you can start to get changes pushed through. And as regards to silos, well, we all know what the issues are with silos, so I won't discuss those in detail. As far as processes go, well, when we talk about DevOps, what we're talking about is an end-to-end delivery process. And what you often find when you start to talk with organizations about the delivery process, they will have a very good vision or very good idea about their little piece of that process, but what happens upstream and what happens downstream and the detail of that is sort of it's very murky and it's lost in the mist. So you have to actually sort of work up the process and you have to work down the process to actually identify all the parts that are going on. And as part of that process visibility, you also run into process maturity, because some parts of the organization will be mature, some parts of the organization won't be mature. And of course, the process maturity then leads into the process repeatability. The more mature a process is, the more repeatable it will be. This can be especially important in areas like testing and deployment, where the sort of knowledge that people have in their heads is very critical to them actually taking out the job or doing their job. One very good example of this was at a Swedish company that I won't particularly talk about, but I'm sure you can guess what it was, where the actual deployment processes were very difficult, very complicated, and very specialized, and they weren't very well documented. So what we had was there were lots of situations where deployments were failing, and when we did all of the root cause analysis, what we found out was that the deployments that were actually good to go were done by people who actually knew, or specialists that actually had done the process a lot of times before, and they actually had the knowledge in their heads about what they needed to check, what the sorts of environment variables they needed to set up were, what the pre-deployment checks they needed to run were, to make actually the deployment successful. Where the deployment failed was because the people who were trying to do the deployment were following the documentation, and that documentation left a lot of uncertainty about what needed to be done. So because it wasn't a very repeatable process, if you like, it was very dependent on the knowledge that people had at the time of that process. It was sort of subject to lots of either working or not working. So it wasn't a repeatable process. And the last thing is, is it measurable? Now, obviously, one of the reasons why you're doing CI and CD, which is continuous integration, continuous deployment, is that you want to show an improvement. You want to actually get the quality up. You want to get the performance up of the performance of the release cadence up. But you can't actually do that unless you actually know what it is that you're trying to measure and you have some way of measuring it. Many organizations, especially some of the ones I've worked with recently, don't have any way or basically work as a black box. You plug something in and the result comes out, but you don't know how long that has taken. You don't know the sort of effort behind the scenes that we've done to do that. You don't even have any visibility about the sort of test coverage. So having the ability to measure things and having the ability to sort of white box it is very important, especially when you start to move to automation. And of course, when we start talking about technologies, we start talking about multiple technology stacks. This is a fun one. No release, if it's for a big organization, will be done on the same technology stacks. It will always involve more than one different type of technology. So that means you have to worry about whether you're sort of using Java 11 runtime, you're using Go runtime, you're using C++ runtime environments, whether you're using different versions of Linux, are you using container applications, are they patched to the right level? Have you done all the security patching that you need to do? All of that sort of fun thing you have to worry about if you have multiple technologies or multiple applications or multiple components that are running on different technology stacks that you need to deploy as part of your system. So there was one very good example of this a couple of years back. I think it was for Equifax, or it might have been Target, where they had a very large security breach simply because they had not updated or had not patched one of the systems to the right level. So being able to understand the different technology stacks you have and the sort of levels that they're at, and making sure that they're patched to the right levels and they have the right dependencies is extremely important. And that's where we start to bleed into environment management. Now, environment management covers the things like I was talking about before, but it also covers ensuring that you have the environments available. Can you spin up an environment to allow people to basically do testing? Do you have those environments available? Are those environments configured at the right level? Are they coming from a common configuration? Have they suffered from any configuration drift? All of those sorts of questions are part of environment management and are a big concern when you're actually trying to implement a stable DevOps sort of solution. I've already talked a little about repeatability and automation, so I'll skip that. And when we're talking about CI/CD and CV implementations, if you're not familiar with the term CV, it means continuous verification, which is basically just like being able to run multiple tests. If you've got multiple components and you've told them, oh, we're going to DevOps, so can you sort of automate what you're doing? How are you going to manage those implementations? How are you going to make sure that they're using the same architecture, they're using the same sort of technology stacks? So there's sort of like a management challenge there as well. And then finally, we're talking about observability, which is again that black box thing. How do you make sure that you're able to get into the environments that you're deploying into and make sure that it's behaving as it should be behaving? So those are all sorts of challenges that you need to sort of think about and consider when you're doing a DevOps implementation. Now, we'll come to the first of these slides that I'm sort of going to skip. These are here to basically give you some questions that you might like to sort of think about when you're actually looking at DevOps in your own context. So what I've taken is each of the main points that I've had before, and then sort of put down some areas that I've been concerned with in the past or that have thrown up red flags in the past. And you can sort of think about how they apply to your organization and how they apply to your sort of DevOps implementation that you might want to do. So there's one for culture, there's one for processes, and then there's finally one for the technology issues. And again, some of these using different languages that you might need to sort of look up, especially things like componentization or monolithic services or managed services. So I will leave that to your enthusiasm on the topic to actually research that on your own and sort of look at these questions and sort of think about how they might apply to your sort of situation. Right, I'm going to not do a break for this one, but I will do a break after I've done this section to see if there are any questions. So we've talked about the issues, we've talked about the sort of high-level boundaries that they sort of fit into, but how do we actually look at how do we solve them? What are possible solutions to these types of issues? Well, here are some suggestions. They're not the only ones, but they might help in actually looking at them. So when we're talking about culture issues, whether it's politics or trust or silos or ownership, there's one sort of solution that fits all, if you like, and that is executive sponsorship. That is the most important thing that you need. from all the implementations of all the sort of companies that I've worked with, executive sponsorship is the most important thing that you need to secure. It's amazing how many problems you can overcome doing implementations. If you can say the CTO is the one that's sponsoring this, and if you have any issues about what we're doing, then we'll be happy to discuss it with you in the presence of the CTO. It's amazing how many sort of problems that magic word CTO makes disappear. So it's always critical to have good, visible executive sponsorship. If you don't have that, then good luck. Other things that you might be interested in having is doing POCs, because those are very good at sort of identifying types of issues and getting evidence. But be very careful with POCs, because some organizations like to use them as an excuse for not actually doing transformation. So basically, that Swedish company I was mentioning, they were very good at doing POCs because it sort of gave them an excuse. Excuse is probably too hard a word, but it gave them a reason not to advance change as much as it should have been. Self-onboarding frameworks. Now, that's a very good way of actually encouraging teams to sort of onboard into DevOps, CI/CD, CV processes, the cloud in their own time. The idea about having a self-onboarding framework is that you create a DevOps framework that sort of allows people to, gives them call outs that they can then code their implementation into, that effectively they don't own the framework. All they're doing is just making use of the framework. Now, if you want an example, if you go to my LinkedIn sort of profile and you go to my GitHub repository from that LinkedIn profile, there is one that I've already written that you can use with full documentation about how to use it. It's free of charge, so you can just grab it and change it and do what you like with it. Other things like close involvement and ownership. Obviously, the more closer you are with the people who are trying to implement the DevOps process, and the more sort of ownership that you sort of share with them, then the more willing they are to sort of trust you and move into it. And lastly, having clear goals and deadlines. I mean, there's nothing more horrible than basically just having some vague goals and vague deadlines for actually killing off a transformation process. Be very clear about what it is you want to achieve, and be very clear about the deadlines that you want to achieve them. Now, obviously, they might not happen, but at least you can have something that people can aim for. Now, for things like inertia, ownership, and silos, I'll basically point you at the previous ones. The list of issue, or the list of sort of solutions that I talked, or potential solutions that I talked about, in my opinion, and from my own practical experience, can help apply to each of those types of cultural issues that I've spoken about before. So we've talked about culture. Now let's talk about process. To some, process is an evil word, but it's very important for DevOps. Now, the first thing is process visibility. And that's basically, how do you identify what it is that the delivery process that you're trying to sort of map, if you like, or you're trying to automate. The best way of doing this is something called value stream mapping. At a very high level, it's like doing process mapping with level 0, level 1, and level 2, and sometimes if you really want to go down to level 3. It's basically a way of identifying what the end-to-end process is, who owns it at different phases of that process, the wait time that you stay on a process, and the sort of outputs from that process. And simply by doing a value stream map, you can very easily identify bottlenecks or things that you can do a quick win by basically automating. There's been very many times where we've done a VSM mapping, and we've been able to identify very, very sort of quick wins that can increase the speed of the performance of the release process by many, many factors, simply by just removing or trying to address that bottleneck with maybe just some automation. For things like process maturity, then things like maturity assessments work great. If you want to know about maturity assessments, look at CMMI. That's a good sort of framework that you can use. Basically, what you do is you take a sort of like a CMMI framework, and then you modify it based on the attributes that you're interested in mapping. Things like maybe, do you have people that are able to automate things in certain languages? Do you have people who understand what CI/CD is? Is a component at a certain level of maturity as far as their processes being repeatable and documented? The same sort of concepts that work well for CMMI work great for maturity assessments. Operational processes, documentation, and automation. That's really down to any operational processes that you have. Make sure that they are documented down to the level that you can actually automate them, because there's nothing more horrible than having a process document that's sort of mid-level, very fluffy, because that means that you can't actually make it repeatable. So when you're trying to do the repeatability, you're obviously looking at the process documentation again, because that's what you're going to be using as your sort of guide for doing the automation. But it also involves doing things like identifying dependencies. So for example, if you're doing testing or repeatable testing, then you'll be surprised how many organizations have a great difficulty trying to create reusable test data. So things like TDM and HCM, test data management and hardware configuration management, can be quite important in basically getting things repeatable in an automated fashion. And when you're looking at automation, then you're sort of looking at things like, what sort of things do you need to automate? How do you identify them? How do you identify the dependencies that automation has? Like the repeatable test data, as an example. How do you automate the gating criteria? So, you've got say like a test suite that's run. How do you go through that test suite and actually automate whether that test suite's worked or not? Doing that gating automation can be quite a significant piece of work. And of course, then once you've got all that, then you have to actually do the automation itself. And then lastly, technology. Now, there's a lot of words in here which if you're not familiar with, then you would be best sort of looking them up and doing some research of them offline, because I'm not going to have time to go through all of them in detail. Containerization, definitely look that one up if you're not familiar with the term. It's very big these days. It's one of the biggest sort of technological implementations that you do, especially if you're using the cloud. Kubernetes, the same, and microservices, the same. Environment management, again, we're talking about containerization. We're talking about infrastructure as code. Now, infrastructure as code, very simple terminology. You take something like an application server. Maybe you have an IIS server or a Tomcat server, and it has certain configurations. It has certain memory. It has certain applications stored on it, certain configurations. What you can do is you can profile that, and then you can create code that will actually mirror that infrastructure setup. And because it's code, you can treat it the same way that you would treat application code. That is, you can version control it, you can change control it, and by using the sort of tools that support infrastructure as code, you can actually fix configuration drift very easily. You can detect configuration drift very easily, and you can actually sort of roll out patches just by simply creating a new version of the code. And then what the tool will do is it will work out what it is that you need to do, or what it is that it needs to do to get your infrastructure up to the point that that's being represented by your code. So it's a fantastic concept. If you're having lots of infrastructure problems, configuration problems, look at infrastructure as code. Managed services in the cloud, I'm not going to talk about those. I'll leave you to research that. And SRE and observability, we've sort of already discussed. Finally, in the technology space is the CI, CD, and CV implementations. Now, if you've got lots of components and lots of teams, then you want to be able to ensure that they are doing an implementation or sets of implementations that work in harmony with each other. Otherwise, you have lots of challenges with sort of tool fragmentation, multiple tool stacks, and you don't really want to go there. So the best way of doing it, as I say again, is to use something like a a single DevOps coding framework that people can then onboard themselves into, or doing things like creating automation templates that people can then just change as appropriate. And throwing in another tool name, things like Kubernetes and a tool called Helm and a tool called Terraform is very good in that sort of area. So those would be things to look at to help you solve those technical problems. Okay, so there's a lot of information there. So I think that's a good point to sort of stop and sort of ask if there are any questions, which hopefully there will be.
So I actually have a question, Tim. I had not really thought about process repeatability and that you needed to have that in place before you can automate. Can you just, how do you know when your process is repeatable?
Well, there's two reasons why you want to make your process repeatable. The first thing is that the more repeatable the process is, then the more or less dependent you have on that shared knowledge. That deployment example that I gave was a very good example of that. Yeah, we were literally, or this company was literally bleeding thousands a month simply because they hadn't tied down that deployment problem. So if you have documentation which is very not necessarily infinite microservice detail or sort of infinite detail, but at enough detail that anyone with some knowledge in the area can come along and do it, then that means that anyone within that group can actually hopefully take on that job and actually do it. It doesn't become a specialized area anymore. The other reason is because if something is documented to that level, then it means that you can automate it very easily. You know, if I'm trying to get a team to automate something and they have a document which basically says, you need to do this, you need to run this script, you need to do this, you need to run this script, and then you need to copy this file from here to here. I can say, oh, well, there you go. That's the instruction you need to automate it. Go away and automate it. If it's something which is at that midpoint where, you know, there's lots of fluffy language in there, there's lots of assumptions that are made based on people's knowledge, then you have to dig deeper. So that it means that the amount of time that you have to do to sort of, you have to track down the specialists, you have to work with them so that you can copy down what they're doing. You may even have to go to the point of shadowing them for a bit if it's, you know, sort of multiple teams that they're working with. It's just a lot more hassle. If things are documented, then and they're well documented at a good suitable level, then the actual ability to implement that automation is a lot easier.
It sounds like a big investment, though. I know certainly organizations that I've worked with find documentation really difficult, and they find that the documents drift from practice.
Yes, it depends really on the type of organization you're dealing with. I mean, I wouldn't recommend, you know, if you've got the same team doing the same work all the time, then it doesn't really make sense having that documented at a well level. They can just go straight into the automation. But if you're working with sort of enterprise scale organizations that sort of are using third parties to maybe offshoring, maybe they've offshored the deployment process and all they do is a ticket. You know, I create a ticket that says, I want you to deploy this to this environment. And you're not even sure that the person doing that deployment or implementing that ticket's actually done it before, then it's at that point that you need that documentation. So it really depends on sort of situation that you're talking about and the context that you have.
Right. Interesting. So I don't think anybody else has any other questions at the moment. So
I've blinded them all with technology. Yeah. lots of lovely terms. No, but seriously, if you're looking at DevOps and you're looking at working in a sort of DevOps cloud environment, then I would strongly suggest you look at things like containerization, Kubernetes, and microservices. That's really, most of the cloud, the way the cloud works these days, it's all set up around those three keywords.
Right.
Okay, so how are we doing for
time? We've still got 8 minutes left.
8 minutes left. Okay, here's a rushed, not rushed, but accelerated discussion through the these implementation roadmaps. Now, there's three types of variations of the same type of roadmap that I usually use with customers. These are what I call team ownership, central ownership, and hybrid ownership. Essentially, there's three phases to it. There's the planning phase, which is where you do that VSM and CMMI analysis that I discussed previously to sort of create or determine what it is you need to do, create your requirements. You then create your DevOps backlog from that requirement list. You create your DevOps architecture. You create your cloud and SRE strategies and supporting processes, whatever you want to do. That's the part of the planning phase. And then basically the difference between the three approaches is how you implement and how you steady state or maintain these that sort of implementation. So in the team ownership model, what you do is you leave the implementation. So you create the architecture, you create the framework that people want to work with, and then you leave the component teams to do the implementation themselves. So the advantages of that is that the component teams sort of have the freedom to implement the solution that they're doing. They own that solution, so that they feel like they own that solution, and then they get encouraged to actually implement something. The challenge is that unless you're actually very specific about the technologies and how you want people to do that, then you'll get lots of variations on the same thing, which makes bringing it all together extremely difficult. The central ownership model, again, you've got the same sort of planning process, you've got the same sort of implementation process, but instead of the teams implementing it, what you do is you have a central team. And this team is either known as something like a DevOps team or a system team if you're using SAFe, or it's more commonly known as a DevX team these days, which is short for developer experience. And basically the idea here is, under the central ownership model, is that this system team, this DevX team, is responsible for creating the framework, and then they work with teams to actually onboard those teams into that framework. So the DevX team sort of does the work to do the onboarding. They automate where they need to automate, and they own that solution going forward. The challenge with that is it doesn't really scale. We've tried that implementation approach at a few customers, and the scaling of it is the real problem. It works well if you've got only a small number of components that you deal with, but if you've got lots of components, especially with the customer I was talking about previously, where we had 243 plus components, that's a non-starter. The one that I like to use, and the one that I sort of recommend people use, is what I call the hybrid ownership approach. And this is, again, the planning process is the same. The implementation process is more or less the same, but basically you have the DevX team or that system team creating the framework, and then it's the component teams that are responsible for onboarding themselves into that framework. So the DevX team will basically create the framework. They'll say what the call outs are that the component teams need to actually populate. The DevX team is then responsible for maintaining that framework, but the component teams are anything beyond the boundaries of those call outs. It's up to the component teams to own and maintain. And that one means that you can sort of scale very well, because effectively it's up to the teams to onboard themselves into it. So you can have multiple teams onboarding themselves into the same framework at the same time, and it works very well. So if you're looking at sort of a large organization that you're trying to move into DevOps with lots of components, then the approach I would recommend personally is that hybrid approach. And as I said, I do have an existing implementation that's sort of based on callouts in my GitHub account. And you can get to that by going to my LinkedIn profile, because it's mentioned in there. So that's really the majority of what I was talking about in this session. So let's just summarize. DevOps covers many aspects, but in the end, it's focusing on release velocity and cadence. It aims to get code changes quickly into production via what we call a CI/CD pipeline. It does require significant investment in automation and organizational change. The main issues that you have to deal with are usually overcoming the functional silos, the trust, the politics, and the delivery process automation. If you do it right, then it will significantly reduce your release times. I mean, you've got companies like Netflix, Amazon, Google, and probably quite a few others I've mentioned, sort of doing many releases a day, simply because they have a very good DevOps implementation. You don't need, it's not rocket science to do. It's just more sort of making sure that you can understand what it is you want to do and how it is you want to do it. And then finally, it does involve many strategic changes, such as cloud usage and this term value streams, which I haven't had time to go into, but I will leave that up to you to research. So that is me. I hope you have found this topic of interest. I hope you have found the presentation useful. As I said, there are articles that are referenced within this presentation as hyperlinks, so that you can sort of go off and read more, hopefully more information about them. So I'll hand over to Kylie and just say, are there any final questions, Kylie? If we've got, use the last 2 or 3 minutes or whatever to have any final questions.
No questions coming through the chat box or the Q&A. I've seen references to, say, a cloud center of excellence. So how does that relate back into DevOps, or sort of this type of way of working that we've been discussing today?
Okay, remember that I was talking about that term system team and DevX?
Right.
That is usually what you call your cloud center of excellence. Well, it's not an exact match, but usually, I say usually because it's a very loose term, but usually the cloud center of excellence and the DevX team have a lot of the same hats that they do. So, for example, one of the clients I was working with, Bank of Ireland, what they had was a DevX team, which were basically responsible for creating infrastructure templates, for setting standards on infrastructure. So they were the sort of cloud center of excellence, if you like. And they were responsible for sort of creating and maintaining templates that everyone had to use. But they were effectively being a DevX team, but being called the cloud center of excellence.
Right.
So they will share many of the same sort of responsibilities. It's basically about creating a ecosystem which supports either cloud or DevOps or both, and then having that being shared or being used by lots of other people. So templates, frameworks, creating them and letting them be used by other people.
Perfect. Yep. No, that makes sense. And I did, when you mentioned DevX, and I could see where it was sitting in the implementation program, I thought, oh, yeah, I wonder if there's a relationship there. So thank you. Great. Well, I think that was a really interesting talk, and I hope everybody enjoyed it. So thank you so much, Tim.